Our goal in this lesson is to get the equation of a line given 2 points on the line. To use them, we have to know what it is we're trying to find. So for any line, you need 2 pieces of information. One of those is a point on the line. The second piece of information you would need then is the rate of change. So from this point, if I know my slope, I can get to all my other points and then make my line between them. We're going to follow that sort of strategy here today. Let's go as follows. I want to find the equation of this line that goes through these 2 points. So just to set it up, so 3, 4, and -3, -1. I'm going to head to my Desmos here and put a point at 3, 4, and a second point at -3, -1. We're looking for the equation of a line that goes through these 2 points. We can use Desmos when we're finished to check and make sure that we have done that. Back now to our work page. Let's go first with the line's slope. Here's the good news. We've already been finding the slope between 2 points. This isn't a new thing. So we're going to take these ordered pairs, set them up in a table. So ordered pair 3, 4 across from each other, ordered pair -3, -1 across from each other. And then let's do our subtractions. So for the change in y, take bottom minus top. For the change in x, do the same thing. Order matters, so bottom minus top, -3 minus 3. That's going to take me to a -6. Let's then turn these into a slope fraction. That's always going to be your change in y number on the top and your change in x number on the bottom. A negative divided by a negative is the same as a positive divided by a positive. So when you've got 2 negatives like this, you should reduce them, cancel them out to leave the positive version behind. The hard work is done. We've got the line slope. So to get now the point on a line, well, my goodness, we've got 2 points on the line. There's no work to do there. And here's the trick. You can choose either point to use in the point slope equation. It doesn't actually make any difference. So your equations may look different, but they'll be the same. Here's what I mean. Let's take a look at the setup first. So y equals space for the slope, x minus, space for the x, plus. This is our setup for the point slope equation. Let's take our slope of 5/6. Let's take the first ordered pair, the 3, 4, and there you go. Here is an equation of the line that goes through those 2 points. To check it, to see if it's right, I'm going to pull up my grapher. So we think y equals 5/6 x minus 3 plus 4 goes through those 2 points. Sure enough, right there it is. Now this answer is perfectly good. However, there's another answer you could use based on this, because I said you could use either of the points. I just want you to see that they both give you the same line in the end. The setup is the same. Y equals space for the slope, x minus, space for the x with a plus at the end. Our slope number is the same. It's going to be 5/6. For the point, though, we've got a -3, and then we've also got a -1. Well, when you've got minus a negative and plus a negative, I want you to clean it up a little bit. So leave the slope the same. Minus negative turns into plus positive, and plus negative turns into minus. Now, here's the fantastic thing. I'll highlight this and let's do it in a different color. This line is going to be the same line that we've already graphed. It looks different, but it's going to end up giving us the exact same points. So coming back here, a new line, y equals 5/6 x plus 3 minus 1. And look at that. It goes right through the exact same place. So when you're checking these, I strongly recommend pulling your computer out, graphing it on Desmos. You type in your ordered pairs just like they look. Then you type in your equation. Make sure it actually goes through those 2 ordered pairs. Let's go back to here and fill in the toolkit. Here we go. Writing a linear equation given 2 points, we find the slope, and then we use either of those points we started with in the point-slope equation. I would like you to, at this point, do a quick pause, try this example, and then unpause when you're ready to check your answer. I'm going to focus first on getting the slope of this line. So for change in y, bottom minus top, minus the negative turns into a plus. So it's like 3 plus 2, which takes us to 5. For the change in the x's, same thing, bottom minus top, which is 3. So the slope then, it's always going to be the change in y number on the top, the change in x number on the bottom. For the equation then, I'm not going to list them both this time. We're just going to pick one. And if I have the choice, I like to pick an ordered pair that doesn't have any negatives in it. It just makes the work a little bit easier. So my final answer, y equals, space for the slope, x minus, space for the x coordinate with a plus on the end. Slope number goes in front, x coordinate of the point, and y coordinate of the point. There you have it. Once again, just for practice, let's do a real quick check. I'm going to pull up my Desmos, clear out what we have, and put our new points in. We had one at 1, -2, and another point at 4, 3. So at 1, -2, and then another at 4, 3. Okay, so a steeper line this time. We think an equation is 5/3 x minus 4 plus 3. So y equals 5/3 x minus 4 plus 3. There we go. We know we've done things right because my line goes through those 2 points. So there's your basic process for finding the equation of a line between 2 points. Get the slope like we've been doing now for a while, and then throw it into your point slope equation from a recent lesson. I'm going to switch back to the yellow highlighter for this one. Put things in, and then check it on a graph.